Filtration essentially is the removal of contaminants from either air or from a liquid via the use of a media.
And that media is then used to trap particles and contaminants that could cause damage and could effectively and ultimately cause a high level of cost to our customers.
With the conditions the machines, JCB machines work in, dusty usually environments, you need good quality filtration.
In simple terms, a media is paper. It's made from either can be cellulose, which is basically made from compressed trees, or it can be synthetic as well.
They have all been specified by JCB to provide the best protection available for each one of the filtration purpose that it's been requested to carry out.
The process of constructing a filter may seem quite simple, but there's a lot of very complex things at work. It has to capture particles down to minute sizes, down to the levels of 2 or 3 microns, smaller than a red blood cell. So to get that material specification correct requires a lot of quality control, requires a lot of diligence by our supplier base and by JCB to specify it correctly. There are other things as well that go into making a filter. It's the sealing, it's the installation, it's the cleanliness during the manufacturing process.
Good filtration is important because it maintains the system performance that JCB designs into its machines. JCB selects its filters very carefully. It looks at a whole range of factors. One of the key things is that it must meet various test requirements.
Air filtration efficiency is measured to an ISO standard. Essentially what happens is that calibrated test dust is injected into an air cleaner. This represents the amount of air going into the engine. Now, what happens is that with the air filtration test, the amount of dust that's injected is then compared at the end of the test with the amount of dust that actually passes. So it gives an overall air cleaner efficiency. You'll come across a lot of people that say they've got a 10 micron filter. What's essential is to actually establish what that means. For example, you can get a 10 micron filter which has a 99% efficiency on 10 microns, and you can have a filter which has got a 99.9% efficiency at 10 microns. They're not the same. The one that's 99% efficient will let through 10 times more particles. The JCB filters are always more than 99.9% efficient.
Like most components, thermal effects can have a big effect on the performance of the component. In a filter media, the media itself can undergo stresses and strains due to the sudden increase in the temperatures, which means that it will not be able to trap the contaminant in the way that it is designed to.
The thermal shock test is where an element is subjected to -40 up to a significantly high temperature, way above ambient temperature. The basis of this is to simulate real-world conditions where you could go from very, very cold conditions right the way to very hot conditions. The test itself is very severe in that it literally changes from -40 to very hot temperature within 1 to 2 seconds, so it's a really, really severe test. The idea is that this tests out seals to make sure that seals can withstand operating in various conditions. It also measures that the media can operate in those conditions, and it also ensures that any sealing compounds used in putting the element together it can withstand that.
Sealing is as important as the filter material itself.
It prevents any air bypassing the filter mechanism that you have put in place to protect your component system. So therefore it's essential that it seals correctly time after time after time.
The JCB elements or JCB filtration products are put through a shaker test, and this shaker test is an off-highway test which signifies or represents the very, very severe vibration levels that can be seen on a construction machine. And what will happen is it will be tested in 3 different directions using a prescribed input onto the shaker table, and the idea is that the parts can withstand that, and this effectively simulates an entire life on machine.
JCB seals should be designed for the original fit and the tight fit, so it doesn't bypass, whereas an aftermarket filter might not be designed to such rigorous testing and fit.
The filter itself is a fairly low cost compared to the rest of the system, but it's really the most important part of any system.
Alternative filters from other manufacturers, for example, might look the same, but may not reach the service interval, in which case then the filter will start to go on to bypass, will break down.
There is a few customers who fit cheaper filters, but generally, compared with the damage that they can do to the machine by not having the correct filter, it's insignificant really, the price difference.
What you get is protection of your system, and therefore ultimately a more reliable machine, and therefore carries greater value to it at the end when it gets traded.
You work on the assumption that JCB is only going to give me a filter which is suitable for that machine, and it's going to do the job in that machine that you want it to do in that machine. And if you use the right filters, it's going to last longer. So better maintenance, better time you're going to have, less breakdowns you're going to get. The less breakdowns you get, the less money you lose.